So this leads us to the last section of our lecture, chemical cycling. The way that chemicals cycle through the ecosystems. It's going to involve biotic and abiotic or geologic components. And we call these biochemical cycles, the water cycle, the carbon cycle, the phosphorus cycle, and the nitrogen cycle. Chemical cycles may involve a reservoir, which is not available to producers, like fossil fuels and minerals and sediments. Also an exchange pool, which is the source from which the organisms generally take the chemicals, from the atmosphere, from the soil, from the water. Also a biotic community, which is how the chemicals remain in the food chains, and they may not ever enter an exchange pool or an abiotic area like the atmosphere, soil, or water. But it's important to note that human activities result in pollution because they upset the natural balance of nutrients. Now first, the water cycle, or the hydrologic cycle. Fresh water evaporates from bodies of water. Condensation occurs when that vaporized fresh water rises, collects, cools, and it falls as rain, which is precipitation that enters the ground, the surface waters, and the aquifers, and eventually that water returns to the ocean. So this is just a picture of what we talked about. You've got evaporation of the water from fresh water evaporates from the bodies of water from the ocean here. And then you've got condensation up there in the clouds, and it then falls to earth as precipitation, and then eventually it's going to enter the groundwater or the aquifers and end up back in the ocean. The next cycle is the carbon cycle. You know, the atmosphere is where we have carbon dioxide. That's our exchange pool for carbon dioxide. And in water, carbon dioxide combines with water and makes bicarbonate ions. And bicarbonate in the water is in equilibrium with the carbon dioxide in the air. So the total amount of carbon dioxide in the atmosphere has been increasing every year due to human activities, such as fossil fuel combustion. So if we look at the diagram, you see you've got carbon dioxide in the atmosphere. Well, basically you've got photosynthesis removing it from the atmosphere, and then you've got it getting in the water and producing bicarbonate ions. But it's put back into the atmosphere by decay of dead organisms, by respiration. When we breathe, we exhale carbon dioxide, and from our factories, combustion and driving our cars and all those kinds of things, and burning and cutting down our forest, we are producing and putting more carbon dioxide back into the atmosphere. So that's why it's increasing more. Not a lot takes it out except for photosynthesis and the bicarbonate ions in the water. Now the greenhouse effect, we have greenhouse gases, carbon dioxide, nitrous oxide, and methane. And they allow sunlight to pass through the atmosphere. But it reflects, these greenhouse gases accumulate and they reflect infrared or heat back to the earth, and they trap heat in the atmosphere. So the Earth's temperature rises, and this is global warming and climate change. And if the Earth's temperature rises, then more water evaporates, more clouds form, and we can set up a potential positive feedback loop because we're trapping the heat from the sunlight, and it's causing more warming. This is something that's in the news a lot. The phosphorus cycle, phosphorus does not enter the atmosphere. It is found in sediment. It is incorporated into a lot of organic molecules, and it's found in our rocks and in our soil. And if we have excessive levels of phosphorus, it leads to water eutrophication, which is over enrichment of the water, and it'll cause um, blooms of algae and so forth that cause problems. So if we look at the phosphorus cycle, you can see here that it's in the sediment, and um, it's put into the sediment by and in rocks. And we mine those phosphates, and it puts it into the soil. Weathering of the rocks puts it into the soil. Fertilizers put it into the soil. And then you've got sewage treatment plants that put it into the soil. So a lot of it is going to go into our sediment. And it doesn't enter the atmosphere. The nitrogen cycle is atmospheric nitrogen, and we can't use that nitrogen. There's about 78% of our air is nitrogen. It needs to be made available to plants, and it's done this because there are nodules on the roots of the legumes that can fix this nitrogen so that living organisms can use it. Nitrification is the production of nitrates, which plants use as a source of nitrogen. And if you look at any fertilizers, it's always got a nitrogen content because living things need nitrogen. Assimilation is when the plants take up the ammonia and nitrates from the soil and use them to make proteins and nucleic acids. And then denitrification is when that nitrate is converted to nitrogen gas. And animals get their nitrogen from eating the plants. And here you see the nitrogen in the atmosphere, nitrogen fixation occurring from those nodules on the roots of some of those plants is what releases that nitrogen, and so that the plants can take it up, and then the animals eat the plants to get that nitrogen. Problem with nitrogen is it can cause a type of pollution called acid rain or acid deposition. And this is when the nitrogen oxides and sulfur dioxide are converted to acids when they combine with water vapor. And it'll affect lakes and forests, and it will kill crops. So it can be a serious problem.